Hey guys, welcome back once again to HVAC Tech. This time I'm going to show you how to pretty much read the model number of the compressor so you can find out the BTU capacity, the voltage, the application, the amperage, and a lot of this good information you need to know about compressors. Also, we're going to try to find out if this evaporator it matches this compressor. Okay, so let's start with what's the function of the compressor. And the function of the compressor, you guys get close a little bit, is pretty much to adhere or suction the refrigerant that actually coming from the evaporator. This line right here, the one with the insulation, this is the suction line. I'm actually going this way, but actually the freon goes from the evaporator down this way, around into the king valve and into the compressor. Okay, this is where the compressor is going to suction all this freon that is coming from the evaporator. By the way, the refrigerant is 100% vapor, right? It has to be 100% vapor. Once that vapor refrigerant goes into the compressor, and this is the, I guess, the big deal here, the refrigerant is being compressed. As it is being compressed, the temperature and the pressure goes up. So from, let's say, 26 psig on a cooler, you will compress up into 146 psig. Let me move the car around. So the compressor sends the refrigerant into the condenser at about 146 psig. And by the way, I'm talking about a cooler. This is a cooler 134A compressor, right? So that refrigerant, 143 psig, high pressure, high temperature, goes into the condenser. Once it goes into the condenser, we got a fan on the condenser, which the refrigerant moves into a couple of feet of copper. You can see all this copper, and as it moves into all this copper, there will be a fan blowing air from here across the compressor, across the condenser, in which then that refrigerant, hot refrigerant, high pressure, will go down, only the temperature, and then the refrigerant comes out of this pipe right here, which is the exit of the condenser. The pressure would not change. The pressure will stay the same. The only thing that changes is the physical state of the refrigerant. It used to be 100% vapor, high temperature, and now becomes liquid. So the pressure stays the same. Now the refrigerant will be liquid 100%, which then goes into the king valve, and then from the king valve goes into the filter dryer, and then from the filter dryer goes into a metering device, and from the metering device this goes into the evaporator. All this process here, this is 100% high pressure liquid refrigerant. As soon as it passes the metering device, this refrigerant, it actually is now boiling. So it will be liquid, low pressure, because this metering device is going to bring down the pressure down. Liquid boiling into vapor, and once it goes into the evaporator and the fans are running, then it's going to add heat from the space into the refrigerant, and now that refrigerant becomes from liquid low pressure, it becomes now vapor low pressure. And that's the way it's supposed to happen. Here in the evaporator, it has to come up 100% vapor, no liquid. That vapor comes out of the system once again into the suction line, which this is insulated, and it goes down into the compressor once again, and the process is being repeated 1 to 100 times. All depends on the system, you know, as long as the system is running, it's usually just really happening the same thing. Okay? This is just a basic information, so this is a lot, you know. I mean, when someone asks you what is the purpose of the compressor, you don't have to give it all the steps. I just want to give that information to my students so they remember this information, that it's going to be a video about it. But pretty much the whole process that I just explained, it's a good explanation in a way that what is the whole general thing. But just the basic information on what the compressor does, pretty much the function of the compressor is to increase the temperature and increase the pressure of the refrigerant. That's it. That's the whole thing. Increase the temperature and increase the pressure of the refrigerant. This will be 24 psig, this will be 145, 146 psi coming out of the compressor. Cool? All right, now we're going to talk about types of the compressors. For example, this compressor is a rotary compressor, and we also have what is called reciprocating compressors, and we also have what is called scroll compressors. The scroll compressors in this business and in refrigeration, they're using it right now. So there's a lot of scroll compressors. They finding out that scroll compressors are high efficiency and they work really, really good in refrigeration systems. So back in the day, reciprocating compressors were the number one. Right now, it seems like we're moving to scroll compressor system, and actually they're becoming number one. Why? Because they're easier it's not too expensive to build, and actually less moving parts, high efficiency, and you know, the companies who make the compressors are pretty much are getting a better deal to deal with this type of compressors. Okay, so right now this is not a scroll. This is called a rotary compressor, and this is very common for refrigeration systems, for very small systems. All right, a scroll compressor, that will be taller, thinner and taller. That will be something completely different than this one, and that will be used for large refrigeration systems. Okay, and reciprocating compressors, they normally are a little bit bigger, and they will be more a little bit heavy duty for air conditioning or for refrigeration. Okay, so in this case right now here, this is a rotary compressor. It's a really good. It's high efficient too, very, very good. It's only doing just for a refrigerator. It's not for a big system. Okay. Now that is the types of the compressor. Now let's move into the model number of the compressor. Let me put it to the side, the system to the side, and if you guys get closer to the camera, there will be two numbers here on your model number of the compressor. They look very similar, right? This one at the top, this is not the model number. It's always going to be the one at the bottom for the Tecumseh compressors. So my model number is a TPA 9419YXA. Okay, well, all this information here will tell you the voltage, the application, the refrigerant, all this stuff. How can I find out from this? Well, right here. This is a chart that I send to my students, and by the way, you don't have to pay for this. You can download it from Tecumseh website. That it tells you for every one of those letters, it equals for something. Okay. For example, I don't have time to go over everything, but let's find out about the application. The application for this compressor, it could be a low temperature, a high temperature air conditioning, excuse me, or medium temperature. Let's take a look at the number. It says the application will be the fourth after the two letters, actually three letters, the first number. So it says AE4A, all right, or A4. I'm sorry. So let's go back to the model number. It says TP, that's the two letters, and then A, that's that one, and then a 9. This one has a 4. This example is a 4, but my real compressor has a 9. So let's follow the number 9, and there you go. Number 9, it says this is a commercial, plus 20 degrees, high motor starting torque, and rating point, plus 20 degrees, and this is for commercial. Okay, because we have a, let me see, TPA, let me double check that. Yep, a 9, and there you go, that will be a 9. Is that right? I'm doing it wrong. TPA 2A, release variant, application, yeah, that will be the 9. And the 9 is the commercial plus 20. Okay, so there you go. That's my application, 9, commercial plus 20. Now let's take a look at the BTUs. The BTUs, it will be the next number, which is the number of the digits of rated BTU capacity, and then the first two digits of the rated BTU capacity. So after the 9, I have 4. So the number 4 says there will be 4 numbers total on the BTU capacity. And then I got a 19. So out of that 19, what you're going to have to do is add 2 zeros. So this compressor is 1,900 BTUs. Once again, remember what it says here. numbers of digits in the rated BTU capacity, all right? And then here, first two digits of the rated BTU capacity. So number of digits, it will be, in this case, this example says 4, right? And this example says 4 again. So you gotta count 4 numbers, okay? And then first two digits of the rated capacity is 40. So first total numbers, and you get a 19, so it's 1900. So it's 1,900 BTUs, this compressor. This is the BTU capacity. And then also we're going to talk about the voltage. What's the voltage going to this compressor? XA, this example, and the XA example is supposed to be 115 volts, 60 hertz, one phase. Okay? On this compressor, it actually is YX. Let me see that. Actually, yeah, it's YX. And the YX, that would be wrong. Actually, let's see, 9XA. No, it's XA, I'm sorry. It's the last two digits. Yeah, because this one doesn't come out here. So it's XA. So it's XA. Yeah. XA is 115 volts, 60 hertz, single phase compressor. Okay? So this is a little bit of the information and how to identify the BTUs and the voltage of this compressor. So this compressor will run at 1,900 BTUs. All right? Now, I did my homework and just to show you how to use this to identify the compressor, but then also I went to the website because, by the way, if you cannot get the information using this tablet, go to Google. Go to Google and just type in Tecumseh and the model number of the compressor, and this is what I got from the Google, from the website of the Tecumseh. And once again, motor torque, high starting torque. Look at the BTU capacity right there, 1,920, and that's the number that we find out with the special chart with this one. So once again, you can do the internet, you can do the chart, and right there, 1,920 BTUs. Then also gives you the weight of the compressor. Another important information, it also gives you your resistance. Motor resistance ohms, the main winding, which it says, I believe, 0.97, and motor resistant ohms to start winding 5.9. So that's a good information to find out if the compressor is electrically fine using this information, okay? More information, actually this is more, and this is a really good one here. Look at what happens here real quick. We're gonna go over this real quick. Evaporator temperature, by the way, this is a cooler. So on a cooler evaporator temperature, you're talking about 25 degrees right here. So here we go. On a 25-degree evaporator temperature, and then we got the BTUs, right? Let's say the temperature outside is about 80. 80 degrees is a perfect temperature for a condenser. 80 degrees, 25 degrees evaporator, look at the BTUs, 3,070. So if your condenser is at 80 degrees outside temperature, you should be able to run, or you should be able to get 3,070 BTUs per hour. Look what happens when you expose the condenser to a higher temperature. Look at 90 degrees. Now what happens? 2,850. What about 100 degrees? What if it's 100 degrees in the restaurant? They don't have air conditioning. Look what happens. 2,630. So what I'm trying to show you here, guys, what I'm trying to show you is that hot as it gets outside, the hot the condenser, the temperature outside is to the condenser, the less BTU capacity you're going to get. Look if it was 140 degrees. Look at what happens to the BTUs. 1,740. Okay? So the whole point of this is, you guys understand, so when we do refrigeration, is that high temperatures to condensers like this is pretty much BTU capacity actually goes lower. And if the temperature inside the cooler it's been between 38 and 40 degrees, everything is fine as long as if the compressor's outside temperature is 140, you know, here is about 30 degrees, whatever, 38 or 40 degrees, then everything's fine. Everything should be fine. But if let's say you change the start capacitor to the compressor and the temperature outside is 140, example, right? And you wanted to bring the temperature from 60 degrees, from the room temperature on the walk-in cooler 60 or 80 down to 30 something, 38, 40, this is going to take time. Why? Because the temperature outside is too cold. The temperature outside is too hot, and this is going to make this compressor to run less BTUs. Okay, so it's important you guys understand this. Hot temperature to the compressor, it's a big problem. And of course, you're always going to make sure that your condenser, this is your condenser right here, make sure that it's clean. Sometimes your condenser, it's just going to look clean like this one, all right? I have some experiences where it looks clean, but then I grab my air compressor and I just blow through it, and you're going to see a lot of dust coming out. So when you look at it, it looks clean, but once you start cleaning it, you're going to see it's really dirty. So sometimes it's just dirty inside that you cannot see it, right? So it's preferred to use pressurized air to clean the condenser. Cool? Now, the other thing I just want to cover real quick is about the compressor capacity. Remember, this is, what was the capacity? 1,000 or 1,920 BTUs, this compressor. All right? Now, let's take a look at this evaporator. This is the MG120. So this is 1,200 BTUs. Okay? This is 1,200 BTUs. BTU capacity evaporator. So it seems like this is about 800 BTUs more than this evaporator. Okay, that's what it looks like capacity. But I want you guys to understand something. Okay, this might be a little bit too big, maybe a little bit big for that evaporator. But I want you guys to understand something. We're talking about refrigeration. Refrigeration systems. Remember, let's say this is a unit for a restaurant. One of those restaurants are really busy, okay? How many times they open the doors into those units? When they're preparing the sandwich, when they're making the pizza, how many times they have to open those coolers back and forth? A lot of times. And every time they open it, they will heat. By the way, heat moves to cool. Heat will move inside into the cooler. So that makes this compressor to work and work pretty much all day. Just think about this. If this compressor was only designed, the BTU capacity will be only designed perfectly for this evaporator. This is 1,920 BTUs. Let's say this was 1,900 BTUs. If this capacity is the same as this capacity, just imagine those days when it's going to be really hot. Just think about this. What is one of those days going to be hot? Let's say they didn't clean the condenser. Let's say the temperature in the restaurant is really, really hot because the air conditioning went down. What's going to happen if it's the same capacity? Then the compressor is not going to be able to handle. So the point, what's the point I'm trying to make? These compressors, this condenser unit, they're always a little bit oversized to satisfy the evaporator. Okay? The evaporator should be a good size for the whole cooler, reaching cooler. But the compressor, they're a little bit oversized based on the evaporator. Why? Because they know that they're going to open the doors from the cooler so many times. They know the temperature is going to go up in the restaurants. They know that they're not going to clean the condenser. It's going to become dirty. And then, even though the unit is really dirty, they still have to bring the temperature down. Okay? I don't know if you guys ever seen those service calls where the customer says, "Oh, my unit's not running," and then you go to the cooler cabinet and you find out this condenser all full with grease, full with dust. And you're like, man, no wonder. I mean, this is completely dirty. When was the last time you cleaned it? So how is it the unit runs even when it's completely greasy or dust? You know, how it still runs? Because it's running to the maximum number. Okay? So there you go. The whole purpose of this video, once again, is to know how to identify the BTUs of the compressor to compare to the BTUs of the evaporator, and for you guys to keep that in mind. And we also talked about the refrigerant. This is a 134 refrigerant, which has a POE oil. All that information is going to be on the website. And the starting torque. And then also we can find out the BTU capacity of the evaporator. And that will be a different company. Depends on who makes the evaporator. Okay, so all right guys, so hopefully you guys like the video, and hope you guys understand the point of this video, and we'll see you guys later. All right, take care.